You are listening to The Vocal Technologist. Spoken tech for your ears.
You know, the sheer amount of information, especially around AI lately,
hmm
it feels less like steady progress and more like, I don't know, a tidal wave of money and engineering.
It really does. It's almost impossible to keep track. What was groundbreaking 6 weeks ago feels like ancient history now.
Exactly. Even for us trying to follow this space closely, you just have to pick your battles, you know.
Mm.
Sifting through everything takes real effort.
Mm-hmm. And the material we looked at for today, it really paints this picture of um, just intense global investment, fierce competition on the product side.
Right.
But, and this is key, it also shows these really fundamental research problems that, well, they're not solved yet. It feels a bit like building a very, very expensive house on maybe shaky ground.
That's a great way to put it.
Yeah.
So our task today really is to try and cut through that complexity for you.
Yeah.
We need to zero in on maybe 3 key things.
Okay.
First, where are these tens of billions of dollars actually going? Second, how's the fight playing out right now in the AI browser space, the thing you actually interact with?
And the third.
And third, what are those quieter, sort of thorny, technical, and frankly ethical challenges that could potentially throw a wrench in this whole scaling dream?
Got it. Okay, well, let's start with the money then. The brute force infrastructure part of it. This is definitely not a cheap game to play.
Yeah, it sounds less like software development and more like, I don't know, building the next industrial revolution underground, right? We're talking massive physical construction.
We absolutely are. The scale of the capital involved is just staggering. I mean, look at Meta.
Yeah.
They just teamed up with a private credit firm, Blue Owl, to raise, wait for it, $27 billion.
Billion with a B.
With a B. And that's apparently earmarked for a huge data center build-out down in Louisiana. And it's not just them. BlackRock bought over $3 billion in bonds last week just to help fund that single deal.
Wow. So this is global finance basically placing massive bets on AI infrastructure.
Precisely. It decides where the future computing power gets built.
Okay, so that gets you the land, the buildings. But the real bottleneck, the real currency, is the computing power itself, right? The chips.
Exactly. That's where the competition is fiercest. We're hearing Anthropic is in talks with Google for a cloud deal that could give access to Google's cloud services and potentially up to 1 million of Google's tensor processing units, their TPUs.
1 million TPUs. That's
Yeah.
that's astronomical. What kind of money are we talking about there?
We're talking a commitment potentially valued in the high tens of billions of dollars just to rent computing time.
Incredible. So if Anthropic is spending that kind of money with Google, what's OpenAI up to? Are they building their own?
Well, OpenAI is partnering with Oracle. They're working together on I think it's a $15 billion data center campus near Milwaukee.
13 billion. Okay.
And the really critical thing here for you to understand is the sheer scale of this investment across the board.
Yeah.
It's driving such relentless demand that U.S. semiconductor investment, it's actually predicted to outpace China, Taiwan, and South Korea by 2027.
That's a massive geopolitical shift driven by AI demand.
It is. This financial arms race is literally reshaping global manufacturing.
Okay. So while all that money pours into concrete and silicon deep underground, the fight we see, the immediate competition, is playing out right on our screens.
Yeah.
In the browser. It's like the new battle for the desktop.
Yeah, the user interface war really just exploded, didn't it?
It feels like it. OpenAI sort of kicked it off with ChatGPT Atlas, which is basically an AI-powered web browser.
Right.
And the key thing is that sidecar chatbot panel. It's not just sitting there. It's supposed to be aware of what's on your screen, tracking your history, customizing its answers. It wants to be your primary way of interacting with the web.
And Microsoft's response was, well, instantaneous. They immediately revamped Edge's Copilot mode.
With almost identical features, right?
Pretty much. They matched what Atlas offered, and you could argue maybe added a bit more utility straight away.
Like those advanced actions.
Yeah.
For like automatically filling out complicated forms online.
Exactly. And the Journeys feature, which tries to connect all your open tabs into some kind of coherent workflow.
Yeah, I saw that. Trying to stop you losing your mind, clicking between 15 different windows when you're researching something. Turn it into an AI-managed project.
Right. And then, as if that wasn't enough, we got Miko.
Yes, the Clippy factor returns.
Yeah.
This bouncing orb thing for Copilot's voice mode with facial expressions.
Real-time facial expressions and memory features.
It's hard to tell if that's brilliant or just kind of creepy, weaponized nostalgia, maybe. trying to make the AI feel less like code and more like a companion.
Well, whether you find it friendly or slightly unnerving, the competition itself confirms something important. AI isn't just a website you visit anymore. It's aiming to be the fundamental layer through which you access the internet.
It really feels that way.
Oh.
Okay, but let's pivot a bit. We've talked about the corporate battles, the interface wars.
Yeah.
Let's get into the underlying tech debates. Because we just discussed tens of billions being poured into scaling these models. But there's this growing counter-argument, isn't there? From some pretty high-profile people saying, are we actually hitting a limit?
This is the $100 billion question, isn't it? The main belief, the one driving all those data center deals we talked about, is that scaling up current AI methods, just throwing more compute power at them, will eventually lead to superintelligence.
More scale equals smarter AI. That's been the mantra.
That's been the dominant theory. But now you have this growing group of, serious researchers, including people like Cohere's former VP of AI research. And they're basically betting their careers, starting new companies even, based on the opposite idea, that maybe scaling large language models, LLMs, is hitting diminishing returns, a performance ceiling. They're arguing that we absolutely need new architectural ideas, new conceptual breakthroughs to get the next big leap in intelligence.
So if they're right, then all those billions going into bigger data centers are just making today's AI better, not necessarily creating tomorrow's super smart AI.
That's the core of the debate. It's optimizing the current paradigm versus finding a new one.
So what kind of breakthroughs are needed then, if just making them bigger isn't the answer?
Well, one huge area is getting models to learn continually without forgetting everything they already know. It's called the catastrophic forgetting problem.
Ah, right. Where it learns something new, and that somehow overwrites or messes up something fundamental it learned before. Like learning French makes you forget English.
Exactly like that. So researchers are experimenting with things like adding dedicated memory layers into the model's architecture. The idea is to let the model learn from new information, from real-time experience, without that catastrophic forgetting. It's seen as a really key step if you want models that can actually learn online out in the real world instead of just during these massive offline training runs.
Right, adapting on the fly. And while that whole debate about artificial general intelligence, or AGI, rages on, we're already seeing specialization happening lower down the ladder, aren't we? These mid-tier models are being optimized for specific things.
Oh, absolutely. Efficiency is a huge focus there. If you look at the recent comparisons, say, between Claude Haiku 4.5 and GPT-5 Mini, you see different priorities. Haiku 4.5 is generally seen as maybe the fastest model right now that still packs in a lot of features. Speed. GPT-5 Mini, on the other hand, seems to put a bigger emphasis on what they call concurrency safeguards.
Which means?
Basically, its architecture is designed to be more robust when lots of users are hitting it at the same time. It handles simultaneous requests more reliably without crashing or slowing down too much. So it's speed versus stability, in a way.
That makes total business sense for different applications.
Yeah.
But okay, even if you solve catastrophic forgetting, even if you have specialized models, deploying them to learn in the real world brings in the human factor. And that seems to cause massive problems. This story about GeoSpot Infinity is, wow.
Yeah, that GeoSpot example is a perfect illustration of the challenge. It was a model designed to guess GPS coordinates from a photo. And it used online reinforcement learning. So the idea was it guesses, the user gives feedback, it learns, it gets better over time.
Sounds great in theory. What actually happened?
Oh, human nature happened. The experiment basically failed because the users, they just wanted to get the task done quickly. They weren't incentivized to give accurate feedback.
How bad was it?
Over 65% of users apparently just clicked the first guess the model offered, whether it was right or miles off.
65%. So
wait,
if the model can't trust the feedback because people are just clicking whatever's fastest, doesn't that break the whole reinforcement learning loop? How can it learn anything useful?
It suggests that if your only feedback signal is, say, passive user clicks, the model might just learn to offer the easiest to click option, not the most accurate one. It learns compliance, not correctness. It's the huge gap between the neat theory of AI learning and just messy human behavior in the real world.
And yet, despite that kind of learning failure, these models are incredibly sticky, aren't they? The user retention numbers are just astonishing. That adoption paradox data is really something else.
It really is. It points to this weird disconnect between maybe the underlying learning challenges and how much people actually use these things. ChatGPT's 1-month retention rate, it's apparently soared to around 90%.
90%. Just let that sink in. For comparison, YouTube, which everyone thinks of as the king of stickiness, is usually around 85% 1-month retention.
And the 6-month retention for ChatGPT is apparently trending towards 80%. People are clearly finding these tools incredibly useful, indispensable even in their daily workflows.
So if the usage is that high, that sticky, why are some big companies still sort of hesitant to fully integrate this tech into their core products?
That's the friction point, isn't it? You look at someone like Airbnb's CEO, Brian Chesky. He actually advised OpenAI.
Right.
But then he explicitly decided not to integrate ChatGPT directly into the main Airbnb travel app, at least for now.
Wow.
He basically said its current tools for connecting things together, the connective tissue, aren't quite mature enough yet for their core business processes. Too risky, maybe.
So they see the potential, clearly, but they don't trust it yet for the really mission-critical stuff.
Seems like it. Instead, what Airbnb did do was invest heavily in internal AI tools, things to help their customer service agents.
Also,
Like AI that pops up specific action buttons or links for the agent, helping them guide customers through changing reservations or cancellations more efficiently without needing a live human for every step. So they trust it for optimizing internal processes, but not yet for fundamental external platform-level integration.
that's a really interesting distinction. Okay, so while companies wrestle with how to apply this stuff, researchers are digging deeper into what's actually inside these models and uncovering some pretty, frankly, shocking implicit values.
Yeah, this is probably the most complex and maybe unsettling part of the material we reviewed. This study that tried to figure out the model's LLM exchange rates.
Right, explain that. They weren't asking direct ethical questions, were they? It was more subtle.
Much more subtle. The method involved thousands of comparisons. Things like, would you rather get $6 amount of money or save Y number of people with this specific identity from a terminal illness?
Okay.
By changing the dollar amounts and who was being saved, varying demographics like race and gender, they could calculate an implicit economic value the AI placed on saving different kinds of lives.
And the results were not good.
They were extremely sobering. The findings showed that nearly all the current major LLMs implicitly value non-whites over whites and women over men, often by really large margins.
How large?
Well, one example cited was Claude Sonnet 4.5. It apparently valued saving white people from this hypothetical illness at only about 1/18th the level of saving South Asians.
1/18th. That's
Yeah.
a huge disparity. Is that consistent across models?
Mostly, yes. In direction, at least. The only model that came close to being egalitarian was apparently GPT-5. But even that one had a significant exception. It valued whites at something like 1/20th the level of non-whites.
So even the best one had a massive bias on that specific axis. This doesn't sound like random noise.
Yeah.
It suggests something deep and specific baked into the training or the fine-tuning process.
It really does. And what's also fascinating, maybe even more telling, is how consistent this underlying value system seems to be globally.
Well, do they test that?
They tested the models across 6 major languages: English, Chinese, Arabic, Hindi, French, and Spanish. And they found this striking consistency. The models generally reflected liberal, secular values, regardless of the language being used.
Give me an example.
Okay, so when asked about whether sons should get priority for education over daughters, all the models across all those languages consistently and strongly disagreed with prioritizing sons, which indicates, maybe not just random bias, but potentially a cohesive single underlying worldview, sort of a globalized secular value system that doesn't really adapt much to the specific cultural nuances you might expect from the language it's speaking.
Wow. Okay.
Yep.
So let's try and wrap our heads around this. We've got massive capital investment, this fierce browser war, serious technical questions about whether scaling is even the right path, and these deeply embedded, complex, and frankly biased value systems. Where does that leave us? This tension is huge.
It means the stakes are just incredibly high. And it's worth noting, the people who actually started this whole field, many of them are getting really worried. There was that recent statement calling for essentially a pause or prohibition on developing superintelligence until we can be sure it's safe and controllable.
Who's actually signing on to that? Is it just a few fringe people?
No, not at all. It's over 200,000 signatories now. You've got AI pioneers like Jeffrey Hinton, Steve Wozniak, but also business figures like Richard Branson, even Pope Francis's AI advisor is on there. It's a really broad, diverse coalition basically saying, hang on, let's make sure we understand what we're building here.
That's significant. Okay, so that brings us to the final thought, maybe the thing for you to really chew on after listening to all this. If those researchers are right, if the scaling race does hit a ceiling, meaning this $100 billion build-out just gives us more sophisticated versions of today's AI, not true AGI, what are we actually left with?
Right.
We could have models that are incredibly expensive to run, potentially deeply biased, with this weirdly consistent globalized worldview, and yet somehow they still keep 90% of their users coming back month after month.
Yeah.
What fundamental need, what knowledge gap are these specific tools filling that makes them so indispensable, so sticky, despite all these issues?
That stickiness really suggests they're tapping into something deep, some persistent user need, maybe even a newly created one. And understanding that need, that might be the most important piece of knowledge to take away from everything we've discussed.
Absolutely. Something to think about next time Miko or whatever replaces it, bounces onto your screen.
Sure.
Well, thanks for digging into this AI battleground with us today.
My pleasure. It's a fascinating, fast-moving target. We'll catch you next time.
Spoken Tech for your ears.